Hello, my name is Minhas, and today I will be answering the Communication Task 3 math question. I'll be answering challenge number 1, which asks to use the method of completing the square to rewrite x squared subtract 6x plus 12 in the form of x plus b squared plus c. I will be using algebra tiles to help answer this question. Now, something to keep in mind is that the sum of the area of each algebra tiles need to be the same as the quadratic, so that the equation isn't changed. So here I have an x squared tile, 6 negative x tiles, and 12 1 tiles. To complete the square, all we have to do is rearrange these tiles so that they are in the shape of a square with side lengths x plus b, and then with some 1 tiles left over, which will represent c. To rearrange these tiles, let's start by placing the x squared tile, because it's already in a square shape, and it's going to help us arrange the rest of the tiles in the shape of a square. Next, we can start arranging the negative x tiles. There are two positions where we can place the negative x tiles, which are at the top right corner of the square and the bottom left corner of the square. And since we have 6 negative x tiles, and we have two positions, and an equal number of negative x tiles must be in both these positions, what we can do is we can take 6 and divide that by 2, and that will tell us exactly how many negative x tiles must be in each of the positions. So in this case, 3 negative x tiles must be in both these positions, which means that the area of the top right corner and bottom left corner will be negative 3x. And if you add both these corners up, you'll see that the sum is negative 6x, which is exactly what we started with from the beginning. Now we're left with a shape which has a length of x subtract 3 and a width of x subtract 3. However, the shape is still not complete. We still have to complete the square by adding tiles for the area of the bottom right corner. The bottom right corner has a length of negative 3 and width of negative 3. So we multiply that out to get our area, which is 9. So in order to make this shape a square and to complete the square, we must add 9 ones tiles at the bottom right corner. Now, we just added 9 ones tiles, but in order to keep the total area of all the tiles the same as we started with, we must also subtract 9 ones tiles from the group to the right, which leaves us with 3 ones tiles as our constant. Now we're left with an arrangement of tiles to the left, which creates a square with a length and width of x subtract 3. And to the right, we have 3 ones tiles, which are separate from the square. This is our constant c. Now remember that the sum of all the areas of all these tiles is the same expression as the polynomial which we started with. The area of the square to the left is the length times width of the square. The square has a length and width of x subtract 3, so the area of the square will be x subtract 3 squared. And now we're left with a remainder to our right, which is our ones tiles. And we have 3 ones tiles, so our remainder or constant is 3. And that leaves us with the expression for the area and polynomial, which is x subtract 3 squared plus 3. And that is our answer for challenge number 1. Now, one way we can check that both these expressions are the same is by setting them both equal to the same variable. Here I've just set them both equal to y, and turning them into equations. And by doing that, what we can do is we can graph both these equations. And if they produce the same graphs, then they are identical equations, meaning they are the same and we haven't changed up the equations, we've just rearranged them. So right here, I've just graphed the original polynomial that the question gives us, and I've just graphed it in blue color. Next, I've graphed our equation that we've created by completing the square, and I've just graphed it in golden color, and I will just let you see the graph right now. And as you can see, they perfectly overlap. And since they overlap like that, you can tell that they are the same graphs, and since they are the same graphs, we can establish that they are the same equations. Graphing is great, but it can be very time consuming. So what I've just done is I've created a table of values where I substitute different x values and calculate their corresponding y values for both the equations. So here I have the polynomial that was given to us by the question, and here I have our quadratic, which is in vertex form. And as you can see, for all the x values, from 1 to 5, they all have the exact same corresponding y values. And with the quadratic, it only needs 3 same x and y values, and if those 3 values are the same, then it matches. However, I've just created multiple. I've used 5 x values just to prove a point. And here's the math shown for each of the calculations. Lastly, we can prove that both these equations are the same by using algebra. First, we have the polynomial given to us by the question. Next, we have our expression, which we created using the perfect squares method. We can start expanding the second expression. X subtract 3 squared plus 3 is x subtract 3 times x subtract 3 plus 3. We can distribute the first bracket to the terms of the second binomial, which expands to give us x subtract 3 times x plus x subtract 3 times negative 3 plus 3. We can distribute the coefficients, which multiply each bracket, which leaves us with x squared subtract 3x plus negative 3x plus negative 3 times negative 3 plus 3. We can now collect like terms and simplify, and that leaves us with the polynomial x squared subtract 6x plus 12, and that is the exact same polynomial that we started with. Thank you for watching, and I hope you enjoyed.